Let's get practice with the gradient. The gradient vector is a vector that exists in the domain of a function. Right? This function is a function of three variables, x, y, and z. So it is going to have three partial derivatives, and the gradient vector is the vector of partial derivatives. So I want to find the gradient vector, and then I want to evaluate the gradient vector at a specific point. Let's move all of the relevant information over here. This is our function, and I want to evaluate the gradient at 2, 0, minus 1. So in fact, let's just remind ourselves the gradient vector of a function is going to be a function of x, y, z, at least in this case, because my function is of x, y, z. And it is going to be a three-dimensional vector because my domain space is 3 dimensions. It is going to be the partial with respect to x, the partial with respect to y, and the partial with respect to z, right? If your domain was 4 dimensions, your gradient vector would have 4 components to it. All right. Now, taking partial derivatives, we find that the partial derivative of f with respect to x is e to the y minus y sine xy. So note, when I say partial with respect to x, it is a function of x, y, and z, right? My shorthand, I'll just leave off the x, y, z. We'll understand that this is a function of x, y, and z. All right, the partial derivative of f in the y direction is x e to the y minus x sine xy. And the partial in the z direction is a minus 4. Therefore, my gradient vector, also a function of x, y, z, is the vector of my partial derivatives. So it is the vector of f sub x, which is e y minus y sine x y. The partial in the y direction was x e to the y, oops, not just that, x e to the y minus x sine xy. And the partial in the z direction was a constant minus 4. All right, it's 3 dimensions, right? It's going to exist in the domain of your function. And I want to evaluate this not partial derivative. I want to evaluate this gradient vector at the point 2, 0, minus 1. So if I do that, I'm going to end up at e to the 0 minus, in fact, let's just write it out, and then we'll simplify the algebra here later. It's going to be e to the y, which is 0, minus y times sine of x times y. Yeah, we're going to see a lot of cancellation here. And then the second component is the partial derivative in the y direction, which at this point is going to be 2 times e to the 0 minus 2 sine of 2 times 0. And then the partial derivative in the z direction is a constant minus 4. So at this point, it's going to be minus 4. All right, when the algebra clears the room, this vector is going to be 1, 2, and minus 4.